Hey everyone, continuing from the previous video, we are going to talk about normals. And we know that normals are perpendicular to the tangent at a particular point. Similarly, we are also going to look at how we are supposed to find the equation of the normal at a certain point. And as such, we are going to still use this formula, y minus y1 equals to mx minus x1. That was close. The only thing different from the normal and tangent is actually the gradient. The point x1 remains the same, right? That one is a given, right? Because at this point, the tangent is at this point, right? You see these 3 points, they share the same line. Sorry, share the same point. And that's why the only thing that's different from finding the equation of a normal is the calculation of its gradient. And how do you relate the gradient of the tangent to the gradient of the normal? It's actually through this identity. Gradient of normal multiplied by the gradient of the tangent equals to minus 1. And this is just important, alright? This is just the key to finding whatever that we need. We know that dy dx equals to the gradient of the tangent. That's why we can rewrite this as times dy dx equals to minus 1. And there we have it. The parent equation in terms of the derivative of the function y or function fx, it really depends. And this will help you find the gradient of m, because all you need to do is find the gradient of the tangent and then take the reciprocal over 1, because from here we can get gradient of normal equals to minus 1 over dy dx. Minus 1 over dy dx. And as long as you can find the value of dy dx at the point x equals to whatever, we are able to find the gradient of the normal at y. Find the gradient of the normal at that point as well. For those H2 math students and A math students, you realize this could also be written as minus dx dy, which I'll go through again when I'm talking about connected rate of changes. But for now, just focus on these 2 equations first. Using the first example on tangents, we have y equals to x squared. We know that at the point x equals to 2 is 2, 4. We know that the gradient equals to 4. If you don't know, you can just work it out, alright? Because the gradient of the tangent is 4, the gradient of the normal, equals to just simply minus 1 over 4. And as such, applying the equation of the line, y minus 4 equals to minus 1/4 x minus 2. We then have y equals to minus 1/4 x. Minus times minus equals to plus. 2 times 1/4 is half. Then you plus the 4 here. You will get 4.5. And this is the equation of the normal at x equals to 2. Using another example, let's say y equals to x cubed minus 1. And keep it simple, equation of normal at x equals to 2. First thing first, find what's the coordinates at x equals to 2. So at x equals to 2, at x equals to 2, y equals to 7. Alright, 2 cubed is 8, minus 1 is 7. Then we also have dy dx, okay? dy dx is simply 3x squared. Bring down the power to the front, reduce the power by 1, get 3x squared, minus 1 differentiated, get back 0. At x equals to 2, you then have dy dx equals to 12. 3 times 2 squared, so you see 3 times 4, 3 times 2 squared is 12. What you found is the gradient of the tangent, but we're looking at the normal. As such, the gradient of normal equals to minus 1 over 12. Now piecing everything together, y minus 7 equals to minus 1 over 12, x minus 2 we will then have I equals to minus x over 12 or 1 over 12 times x, whatever suits you, plus 7n1 over 6. And this is basically how do you find the equation of a normal at a certain point.